So it looks like Intel may be doing away with their hybridized architecture. Maybe. But this rumor has certainly led to a lot of discussion online and a lot of people within the PC hardware community that just don't like hybrid CPUs where there's P cores, E cores, and even now LP cores on a specific CPU or a full on package. And I totally agree that monolithic is just king in terms of performance and software optimization and also user experience. Let's discuss that in this video. Hey, what is going on, guys? Danny here. Welcome back to the channel, and I hope you're all doing well. I figured I'd give you guys my input on this latest rumor and discussion surrounding what Intel's plans are going forward for their CPU architecture. Now, you do definitely want to take all of this with a grain of salt. There was nothing really officially confirmed here, and this all is pretty much speculation off of a job posting from Intel. This job posting pertained to a position for their senior CPU verification engineer at their Austin, Texas headquarters, and it specifically says that Intel's unified core team is looking to add a CPU functional verification engineer to their silicon and platform engineering group. And the reason why this is, pretty important to take into account though is because it still means that Intel is still investing internally in some kind of unified core direction while the P-core and E-core hybrid era continues. And in fact, a lot of the messaging over the years from Intel has been how this is the way of the future, how hybrid architectures were here to stay, and this is the approach going forward for all of their future products. And now it looks like they may be doing a pivot here, but it is certainly interesting to see that contrasting message where before they're like, no, we're done with unified or purely monolithic designs, and now it looks like they may be doing a pivot. For those of you who aren't too familiar with this whole hybrid concept or unsure of what I mean, essentially on Intel's current CPU offerings, they're using two different types of cores on them. So for Arrow Lake or Intel's 200 series processors like the 285K, you have 8 Lion Cove performance cores which handle heavier tasks, and those are the cores that you want to be utilizing for your gaming. They clock higher and do also use more power, and they do a lot of the heavy lifting tasks. Then you've got like 16 Skymont E cores, which are used to handle background tasks or lightweight tasks. They don't clock as high as the P cores do, and individually they don't use as much power as a P core does, but they can still be utilized for gaming and other heavy multi-threading workloads for, say, video rendering. It was the same thing on the 12th generation, 13th generation, and 14th generation CPUs as well, based on Alder Lake and Raptor Lake, where there was a mixture of architectures for the P cores and the E cores. Now, the reason why a lot of people, especially gamers, just don't like this design and prefer a CPU with a monolithic design where there's just one type of core, like one performance core, with 8, 10, or 12 regular cores with hyperthreading, kind of like what AMD is doing right now, or what they have done traditionally, is because it just makes software optimization and scheduling a breeze. Whereas, with a hybrid approach, you have to ensure that the Windows scheduler is correctly identifying which cores need to be utilized for what. And if it isn't properly doing that, if thread management isn't handled properly, it can certainly lead to poor performance in terms of lower FPS, but not even just a lower overall average FPS, but inconsistencies with your frame times, which, is actually perceived a lot more. So that's, your poor 1% and 0.1% lows, that variance you have with, the swings in FPS where you might have an average FPS where it's like 120 or 130, but if your 1% lows are all the way down in the 50s and 60s or even lower than that, then it's just going to be a very jarring and nauseating experience. Now, to Intel's credit, they have something called Thread Director, which actually does a pretty decent job at correctly assigning the workload between the P cores and the E cores. And one of the reasons why I was prompted on making this video is because, on my channel, I have done multiple videos and multiple tests where I would disable E cores on a 13700K or the 14900K, and then I would benchmark the game using just hyperthreading, or where I'd actually disable hyperthreading and then just keep the P cores enabled and the E cores still enabled. And, a lot of people swore that they found performance was better by just disabling the E cores and then running their CPU like a traditional, like monolithic CPU with the P cores and hyperthreading enabled, because then the game just doesn't have to worry about mistakenly assigning a load to an E core before it actually has to prioritize the higher clocked, higher power P cores. Now, from my testing, I found that the difference between these configurations isn't actually too drastic in the grand scheme of things. You do definitely have to look at things on a game by game basis, and I urge you to test it for yourself because you can certainly find examples where you have, just P cores running and the game ran better, and you may actually see a increase in your FPS when you have disabled hyper-threading, but not even just, again, higher FPS, but we also have to take into account 1% and 0.1% lows. There were situations where average FPS across all three or four configurations was very similar, but the 0.1% and 1% lows were drastically different. And then the perceived smoothness was, different as a result. I'll have a link to the video I did recently with my 14900K on the test bench where I was showcasing like over 20 games. And that'll give you guys a good idea on what kind of behavior you can expect and what works better for your use case. There's also a number of people who have said that in terms of like, general usability, they perceived more snappiness on CPUs with a monolithic design, whereas on a hybrid CPUs, they felt the latency was just too high. Now, the sluggishness is something that I have actually personally experienced on Arrow Lake, just because of the way the cores and the clusters are laid out there. But you do have to tune that CPU no matter what, which is unfortunate because out of the box, if someone gets it, it may not be running optimally. But on Raptor Lake, on my personal rig, which is using a 14900K, and I've been using this CPU for a little over 2 years now. It's been very, very snappy. I have no complaints, and this is with E-cores still enabled from day one. But circling back to this whole like unified core design and what this can mean for going forward, because with a monolithic or single architecture, you get the benefits of predictability with the scheduler, and where it is a lot less dependent on software optimization or special operatives like a thread director. And obviously, this can result in games running optimally right out of the gate and more consistent with their frame times. Just less intervention is needed there. Now, one of the other important things to take into account here is that Olrag29 on Twitter, who has leaked CPU stuff in the past, does mention that this doesn't actually mean when they're referring to a unified core, it doesn't actually mean that they're dropping performance cores, efficient and low powered cores. He said they do still share the same IP, but with different power curves. So when they mean the same IP, what they're actually referring to are the cores having the same sort of blueprint design and engine design. And if you take a look at the block diagrams or the architectural designs for the Skymont E cores and the Lion Cove P cores, you can see just how drastically different they are. But now what's going to be happening is that they're just going to have like the different clusters operating at different power curves where a certain amount of them can run at really high power targets and clock at like 5.7 or 5.5 gigahertz. And then you'll have an efficient core cluster running at 4.6 gigahertz, and then a low power cluster running at, say, 3.6 gigahertz. And, some of the benefits why Intel will still want to continue doing this is because it will simplify development and also manufacturing. And then they can still scale this across other types of devices like laptops and tablets where they don't necessarily need to be shoving like, 8 P cores or 10 P cores and run them at super high frequencies. They could just do like 6 P cores and then do like 8 or 10 E cores or something like that. And, potentially this is going to result in a lot more consistent behavior where you just don't have those users experiencing the sluggishness or that high latency. And, overall for gaming, I do definitely see this as a net positive. I'm not undermining E cores. I don't call them meme cores like you might have heard other people calling them because they can certainly be useful in productivity apps, but scheduling when it comes to gaming is certainly crucial because games, they don't all behave the same. It all depends on the engine they're running on, how well they're optimized. Some games are still very single threaded, and some games are multi core threaded, but they may not scale past 6 or 8 cores. And then there will certainly be games that will utilize every single core you throw out there. When it comes to developers, and you guys know how gutted the development process can get these days, they won't have to worry about optimizing their games for the different architectures, taking into account, oh, this CPU has 8 P cores and then it has like 16 E cores, or how do we utilize this and how do we strike a balance? Like in Cyberpunk 2077, the devs actually had to specifically add a P core mode because there were people complaining that the E cores were causing massive stuttering for them. And in my testing, I did actually find that utilizing the P core mode did actually boost performance and actually gave better stability with the frame times. And, not everyone is also comfortable with going into the BIOS and disabling hyperthreading or disabling E-cores. And also not just that, they just don't want to have to set up different profiles for like a specific games. Like we're talking about end users who at the end of the day, after working or whatnot, just want to unwind and spend time gaming rather than having to stare at a BIOS screen. Like it just creates such a big hassle, but with a monolithic CPU where every single core is basically the same class, software optimization and scheduling will certainly be a breeze. Now, my take right now is pretty simple. The job posting doesn't, really confirm anything for that matter. There's a lot of things in development and a lot of concepts that, get leaked or get talked about, and they really don't end up seeing the light of day. You can take a look at patents, and there's so many patents out there where things, the actual products never came out of them. And if unified cores means, a shared design and just different power targets, that could be Intel's way of keeping hybrid, but actually making it feel less messy on the user's end. But as always, for me, real testing is what matters, not, marketing slides, not tweets or leaks or job postings. When there's actual products to test, when there's actual silicon in front of me that I can run on my test bench, that I can configure and, tune, that is when we'll see the truth when it comes to gaming performance, 1% lows and 0.1% lows. But for now, that's going to be wrapping it up for this one, and we'll touch base in the next video. Take care.
If you guys found this video to be informative and entertaining, then leave a like. Let me know your thoughts and comments down below. Be sure to check out the video description for cool links and ways to support the channel, such as using my Amazon affiliate link. And if you're interested in seeing more content like this, then consider subscribing. I'd greatly appreciate it. Thank you guys so much for watching, take care, and I'll see you in the next one.